In today's video, we will learn how to use a spectrophotometer. Spectrophotometers are used to measure the amount of light that passes through a given solution. This is an important concept in science because using a spectrophotometer, we can figure out the concentration of a particular solution. This diagram here shows how a spectrophotometer works. It uses a light source, and when the machine is turned on, this light comes from the source and passes through a lens, as such, and subsequently hits a prism. Prisms separate light according to colors or wavelengths. So when light passes through this prism, the light is separated into red, orange, yellow, green, blue, violet. Each color that we associate with light has a different wavelength. Spectrophotometers look at a solution's ability to either absorb or transmit light at a particular wavelength. So when using a spectrophotometer, we typically select for a particular wavelength. That wavelength will pass through the selector, while all other wavelengths will not be able to pass through the selector. Once a wavelength has been selected, that wavelength of light is going to pass through a sample solution. The machine compares how much light goes into the sample, which we'll denote as I sub 0, and the amount of light that passes through the sample, and we'll denote that I sub t. Spectrophotometers can make two measurements. They can make an absorbance measurement or a percent transmission measurement. Both of these measurements compare how much light passed through as compared to how much went in. Absorbance measurements look to see how much of this light was absorbed, and percent transmission looks to see how much of this light was able to pass through the solution. The concept of relating these ideas of absorbance and transmission to concentration is a concept that is known as Beer's law. Beer's law relates the value of absorbance to the concentration of a particular solution. So two measurements can be made with a spectrophotometer, an absorbance measurement or a percent transmission measurement. Both of these compare the amount of light that went into the sample versus how much came out from the sample. So absorbance is looking at how much light was absorbed by my solution, and the percent transmission is looking at how much light was able to pass through my sample. This scale that we see here shows the scales of absorbance and transmission. On the top, my top is the percent transmission, and the bottom is my absorbance. Neither of these have any units. As you can see from our scale here, when something has a percent transmission of 100%, it has an absorbance value of 0, which means that all light is able to pass through the sample and none of it was absorbed. So 100% transmission equals 0 absorbance. Similarly, if we look over here, we see that if something has a 0% transmittance, it has an absorbance value of 2 or higher. So 0% transmission equals a very high absorbance value. So next, what I'd like to do is to show you how to use the spectrophotometer in measuring the absorbance of this sample of bacteria. As a comparison, I have this tube here that contains a solution that does not contain any bacteria. If you look at the two tubes, you will see that the blank or control is clear and therefore should have 0 absorbance, while the tube with bacteria is turbid and therefore should give us an absorbance value. To use the spectrophotometer, we begin by turning it on by turning this knob, which is labeled the 0% T, and you just want to turn it a little bit until the machine turns on. You will then want to wait 15 minutes to allow the machine to warm up. Once the machine has warmed up, we next want to set the wavelength that we want to measure our sample with. To adjust the wavelength, I'll turn the knob that reads wavelength and turn it slowly until the wavelength that I want appears. In our example here, we will be measuring a sample at a wavelength of 600 nanometers, and you can see from the screen that the machine is now set to 600 nanometers. Once my wavelength is set, I need to adjust the filter to the wavelength that I am working with. Because I am working with a wavelength of 600 nanometers, I will move the filter to the 600 to 950 nanometer side. If I was using a wavelength between 340 and 599 nanometers, I would move the filter back. Once the wavelength is set and the filter has been set, we next want to adjust the transmittance until it reads 0. To adjust the transmittance, I'll begin turning the 0% T knob slowly until the output reads 0. Make sure that you turn the knob slowly as you are doing this. Once the machine is set to 0% transmittance, we can now use the mode button and change the measurement to absorbance. To switch from the transmittance scale to the absorbance scale, I'll press the mode button once, and as you can see from the screen here, absorbance now is lit up and the machine is ready to measure absorbance. Here we have a control tube which is going to serve as our blank. As you can see from this solution here, it is clear and therefore should have 0 absorbance. To blank the machine, we take our control solution, which will serve as our blank, wipe down the test tube with a piece of Kim wipe tissue, open up the sample compartment door, insert our test tube, close the door. Now we want to set the machine to read 0 absorbance. To set my blank to 0 absorbance, I will turn the knob that reads 100% T/0A. I will turn this knob slowly until the output reads 0 absorbance. Next, I take out my blank, and the machine is ready for measuring my sample. I now want to measure the absorbance of this sample. If you look, you can see that unlike the previous sample, which served as our blank and was clear, this sample is turbid. To measure the absorbance of this sample, I will open up the sample compartment. I will wipe down the test tube with my Kim wipe tissue. I will open up the sample compartment door, put in my sample, close the door, and read the number that appears. Notice I have not touched any of the knobs when making an absorbance reading. In our sample here, this has an absorbance value of 0.835. I open up the sample compartment door, I take out my sample, and close the door. When you have finished using the spectrophotometer, we turn off the machine by turning the 0% T knob as such. Some of you may use a slightly different spectrophotometer. As you can see here, this one is not digital, but rather records transmission and absorbance using a needle gauge. Turning on the machine and setting the wavelength is exactly the same as before. To set to 0% transmittance, I will begin by turning the 0% T and reading the top scale until the needle hits 0. Note that there is no mode button here, so now that it reads 0% transmission, we are ready to record the absorbance of a sample. I next take my blank, wipe down the test tube with Kim wipe, open up the sample compartment door as we did previously, put in the sample, and close. I now want to set my blank to 0 absorbance, and absorbance is the bottom scale here. So I will turn the 100% T or 0A knob until the needle reads 0. The needle is at 0, so the machine is blanked and ready to measure my sample. I take out my blank. I take my sample I want to measure the absorbance of, wipe down the test tube with Kim wipe tissue, put in my sample, close the door, and if I want to read the absorbance, I'll read the bottom scale, and as you can see, the needle is around approximately 0.8. This tells me that my sample has an absorbance of 0.8.